Hey everyone, it's Pete Soderling. I'm the founder of Data Council and the Data Community Fund. I'm excited to have another episode of DC Thursday to share with you all. As you know, we interview amazing data leaders who are often starting companies or open source projects and advancing the modern data ecosystem. And today, we're very fortunate to have Anupam Datta, who's the co-founder of a model and AI quality company called TruEra. Anupam is a professor at Carnegie Mellon University, and he received a PhD in CS from Stanford. So Anupam, thanks for joining us and welcome.
Thank you, Pete. Thanks for having me.
So Anupam, we're going to talk a lot about AI quality today and what that really means, and I'm looking forward to hearing your thoughts. But I wanted to sort of start off with a bit about your background. You're obviously very well pedigreed, and I'm curious, like, how did you make the decision originally to go into academia?
That's a great question. I think that decision I made back when I was in 6th grade. So my dad was a professor of statistics, and I have always been very excited about teaching and learning. At that time, I didn't know what field, but I was pretty sure that professionally, I would end up being an academic. And at Stanford, I was very fortunate to work with a number of outstanding collaborators, and it got, that thought got even more ingrained. I was excited about the research I was doing back then in areas around privacy and security. And I was just excited about the whole research experience and the academic life, which combines research with teaching and mentoring and having curiosity-driven research that can go on to have a positive impact on the world.
Mm-hmm. And so how did that transition into the field of AI?
So I continued to work on privacy once I joined CMU in 2007. And over time, over the course of the next 3-4 years, what became very apparent is that some of the big challenges in privacy were arising in the context of machine learning and AI. So as AI models got increasingly deployed, how do these models potentially leak information about the people who are in the training data? And what can we do to train machine learning models in a way that respects privacy?
Mm.
And related to that, I had also started thinking a little bit about studying privacy-related properties of existing systems that are widely deployed. And back in 2014, my research group did a study of the Google online advertising system. And initially, we were thinking about this in the context of privacy, that, for example, is health information about people being used to target advertisements to them, which would be concerning from a privacy standpoint. But relatedly, in an adjacent area, a question of fairness also emerged. For example, are employment opportunities being targeted in ways that make use of people's gender or ethnic racial characteristics and so forth? And one of the outcomes of that study one of the things we discovered in the process of that study was that information about gender was being used to target certain kinds of employment opportunities in a way that raised questions about the fairness of these systems. And under the hood, there's a lot of machine learning driving many of these behaviors. And then we took a step back and started asking deeper questions about why is this kind of behavior, why are these systems exhibiting certain forms of bias based on gender and so forth. And that why question then expanded into the questions around explainability of machine learning systems, and more broadly, how explainability could be leveraged to answer questions of AI quality, questions around fairness, questions around stability and robustness of models, and more generally about understanding how well models will generalize to new data and continue to perform well in production.
Mm-hmm. And so at the time, I think sort of, you know, this umbrella you've defined as AI quality. This research you kicked off many years ago. I'm curious, like, what was the state of sort of the understanding in the AI ML ecosystem at this time? I assume that AI quality was not really a term that was used then. I'm curious, like, what was the state of the union from your perspective?
Yeah, that's a great question, Pete. You're exactly right. Back in 2013 or 14, there was a very small community of people who were starting to ask these questions. And one of the early conferences that got pulled together by a small group of people, and I was part of that initial set, was called Fairness, Accountability, and Transparency in Machine Learning. So the transparency piece is close to what we are calling explainability these days. Fairness has still remained an important topic. And accountability was drawing attention to the fact that as you think about these kinds of technical problems, it's also important to think of them more broadly as socio-technical problems with certain individuals in various kinds of roles who are responsible to ensure that the systems respect certain kinds of societal values. So that conference has now grown to become a very central place for this community that hundreds of people go to. It's now called the FACT Conference, Fairness, Accountability, and Transparency. It has become an ACM conference, and it pulls together folks from computer science and law and philosophy, social sciences. It's grown into a very multidisciplinary community. I think that's one piece of the AI quality problem. It's an important piece, which is the social impact of the technology, and it goes by various names. There's the FACT community, sometimes people refer to as responsible AI. But there's also another set of pillars around AI quality, which get to the heart of how well are your models going to perform in the real world, which is the generalization question. They're related, but somewhat distinct questions. And as we think about AI quality, at least the way I think about it now is, how do you think about how should we go about assessing AI systems and models and data so that we can make a more direct connection to their impact on the end organizational value or business value, as well as the social impact through fairness, transparency, privacy, and other related attributes.
So what you're saying is that there's sort of a bigger grab bag of aspects that go into AI quality, and the performance of the models is only one aspect. There's the bigger questions of, did the model sort of reach the intended business goal? Did it apply its predictions sort of fairly and uniformly? Basically, it's sort of it seems like you're expanding this notion of AI quality. Maybe sometimes people from a technical perspective think of model monitoring, but you're actually making the conversation much larger, is the way I understand it.
Yeah, that's exactly right. And historically, when data scientists are building models, there has been a lot of focus on the accuracy of those models. What are the AUC characteristics, ROC, and F1 scores, and so forth, depending on the type of the model, which is evaluated on the train, test, and validation data. And that was the leading indicator, if you will, of AI quality in the sense of how well will it do in production. What we are seeing now as part of this AI quality effort is that that continues to remain an important indicator of how well the model will do in production in the real world in terms of delivering business value. But there's a whole set of other attributes that one should also assess during model development and on an ongoing basis through monitoring when the model is in production. Some of them you touched on, like fairness-related metrics, for example, which has real significance and impact, especially when this is personal information about people, about individuals, and their lives can be impacted in credit decisioning, in hiring and employment-related use cases where machine learning is increasingly being used, in areas around healthcare, for example, medical diagnostics, and so forth. But for the generalization piece of the model as well, just looking at metrics around AUC and so forth, accuracy metrics, is not a very good indicator. It's not a sufficient indicator of how well the model will do in production. So there are other elements around the robustness of the models. Robustness in the sense meaning that if you change your inputs a little bit, for certain kinds of models, you expect the outputs to also change a little bit. So we see that a lot with image recognition models. For example, facial recognition technology is being fed an input. The image, let's say, is that of Orlando Bloom, and the model correctly recognizes it as Orlando Bloom. And then a few pixels get changed here and there. You would expect to a human, it still looks like Orlando Bloom, but a model that's not robust might end up thinking that it's Drew Barrymore. So we have seen a lot of examples of models that might have high accuracy metrics on train and test validation data, but are not very robust. And so when they're fed these inputs, these images in this example that are slightly different, then they make very dramatic errors in their classification. So that's an example of one kind of AI quality attribute that requires additional constraints during training and adjustments to ensure that models generalize well. Another one is stability of models over time. In that case, what we are looking at is the model does really well on train and test data, and now suddenly you have put the model in production and the world has changed. And some of the relationships that used to be true before are no longer true, and so the model starts performing poorly. Being able to understand and anticipate that that's about to happen and why it's about to happen, what is it that has changed about the world that's causing this change, is very, very powerful. So for example, one concrete instance of this is as models started making their way into production, post-COVID, then some of the relationships that used to be true before may no longer be true. So for example, FICO scores used to be a good indicator of creditworthiness. But in the early days of COVID, when people had gotten payment vacations, then delinquencies were not being reported. And so FICO scores were not going down for folks whose creditworthiness had gone down. So in that time, a model that was relying overly on FICO scores to identify folks who are not going to be able to make the payments would not be a very well-performing model. So that's one kind of example. And there's lots of others. People's spending behavior changed quite a bit during COVID. So models that are marketing models that were trained on old data would not do a very good job of predicting how to target folks with offers and products. So that's another kind of attribute of AI quality, which is if you think about the generalization problem, there's generalization over time as well. And it's extremely important to recognize that relationships that are learned during training may not be persistent over time. So it's important to track and monitor them and debug when performance is starting to degrade. Why is it degrading? And what should we do to readjust the model to bring it up to its original level of performance?
Got it. So basically, you felt like these problems were common enough and important enough, you decided to start a company in the space. So tell us, like, what's the brief origin story of TruEra and how did the company come to be?
Sure. So as I mentioned, we started working on some of these problems back in 2013, 2014. And around 2017, somewhere around August or September of 2017 is when I seriously started thinking about starting a company. And one of my PhD students from that time, Shayak Sen, who was working on these topics around explainability and fairness in particular, and had previously been an algorithmic trader on Wall Street, where he was building and deploying machine learning models in high-stakes use cases. He was also very excited about the idea. So the two of us started thinking about starting a company. And I went around and talked to some of my friends who had successfully done startups in the past. And one of the best pieces of advice I got at that time was to go and have 75 conversations across a range of verticals with potential customers to understand if there is a market for something like this and what the state of maturity of the market is. So that's what we did over the course of the next year. While we were continuing to push on the technology, we spent a lot of time talking to folks across the board in financial services, banking, insurance, in healthcare, number of healthcare providers, hospital systems. We talked to folks in more cloud native companies in the gig economy who were technologically more like not a more traditional business where there are legacy systems and such, but they started off in the cloud and were early adopters of machine learning in the gig economy. So you can guess some of the companies in that space, fintechs, and across the board, there was this recognition that the core of what we are now calling AI quality is extremely, extremely important. And there's a lack of tooling to support data scientists and ML ops folks in going about the job of explaining their models to stakeholders, testing and debugging them, and keeping track of them through monitoring. So towards the end of 2018, Shaik and I incorporated the company and started talking to a few friendly VCs. And through one of those conversations, we were introduced to William Uppington, who was at that time Chief Product Officer of a company called Bloomreach. Bloomreach had been founded by ex-Google folks and was taking algorithmic systems, including machine learning, to enterprise retail customers. And in talking to Will, there was a strong resonance in that he had experienced some of the same problems from a sales and customer success and product perspective, where without the ability to answer questions about what was going on under the hood, the black box nature of machine learning in those days, it was very hard to convince customers to adopt machine learning in use cases where it was central to their business. And so we came together, and Will joined us as a co-founder, and we then raised our first round of funding. It was led by Greylock, and a couple of other investors joined us as well. And so this was in April of 2019, and then we started operating in June of 2019. We're about 2 years in. We have come quite some distance since those early days.
Got it. That's amazing. So tell us about, I think we have a sort of backdrop as to why you believe AI quality is important, but tell us a little bit more about the TruEra solution and how the product works.
Sure. So the TruEra suite of products are aimed at ensuring the quality of AI systems, the models, the data. And there are 2 products that we currently have that work closely together. The first is a diagnostic product, and that integrates neatly into the model development environment. So when data scientists are building machine learning models, the workflow into which we fit in involves them building their machine learning models in whatever model development environment they're used to. A lot of our customers use open source libraries to build machine learning models. XGBoost, for example, is very popular. A lot of Python models. There's also TensorFlow and PyTorch, the neural network frameworks, which lots of folks use to build models. And then there are also folks who use more proprietary platforms like DataRobot or H2O to build models. One of the unique things about our diagnostics product is that it fits in easily into and works seamlessly with lots of models produced by lots of different model development platforms. So there was some intentionality at an architectural level to make our diagnostics product and in general our entire product suite agnostic to the specifics of a model development platform. And that's an area of differentiation and strength for us. And philosophically, we are coming from the standpoint that testing and evaluation and explanation of machine learning models should be tightly integrated with the training ecosystem, but there should also be modularity, extensibility, and independence between that component, between that product and the training platform. And we see that if you think about an analogy with software, for example, the core coding software development IDEs and the CI/CD pipelines tend to be separate and work well with each other. So there's a very direct analogy architecturally to that. And what we're also seeing with our enterprise customers is that they are appreciating that separation while having ease of integration, because it gives them a single pane of glass to assess and keep track of the quality of their models that may have been built in many different model development platforms. So within the same enterprise, there are teams building Python models and teams doing R models and teams making use of platforms like Datta Robot to build models. And they can all go through the same AI quality diagnostics platform to support testing, debugging, and explanation. So that's a powerful area of strength architecturally, and there's a lot of work that has gone into building this kind of platform. So that's number one. Number two, what's unique about our diagnostic product is it has a set of capabilities for data scientists to assess a very rich and comprehensive set of AI quality attributes around explainability, around fairness of models, their stability over time, to conduct error analysis, data debugging, and so forth. And at a core technology level, there are some significant differences in the core technologies for explainability as well that we can get into. So that's the first kind of product. And then the second product, which is the monitoring product, is similarly designed to be agnostic to the specifics of the deployment platform or the backend data stores, and can fit in seamlessly into the production environments to support ongoing monitoring. And there again, we have a set of unique capabilities for data scientists and MLOps folks to keep track of their models, get alerts, along with the root cause analysis of why those alerts are being sent. So I'll pause here. There's lots of detail we can get into in each of these buckets. But if you want to take the conversation in a specific direction, happy to get into more details.
Got it. Yeah, so I guess just to understand sort of the broader place where this is applicable, talk to us a little bit about what customers and what industries have found this technology most useful so far.
Yeah, absolutely. So I think in terms of our vision, we believe that this kind of AI quality products is going to be important across the board. So pretty much anyone who's building and deploying machine learning models needs an AI quality solution to help them with testing, debugging, explanation, and monitoring of models. And we are starting to see evidence of that hypothesis, that it's a very horizontal offering that's useful across the board. Some examples of where we have found traction and resonance includes financial services. For example, major banks, as they're starting to use machine learning in various kinds of use cases around credit decisioning, fraud detection. Those are areas where there's a very clear need for AI quality assessments and leveraging that guidance to improve their models. As you may be aware, in the US, there is a lot of regulatory activity around this area. The major regulators for the financial services companies, the OCC, the Federal Reserve, and the Consumer Financial Protection Bureau, have put out an RFI, a request for information, around the use of AI in a way that speaks very directly to the problem of the quality of the models and the associated model risk. There is guidance that is starting to emerge in various other parts of the world. The EU regulation draft that was being circulated for AI talks about an AI quality management system that various enterprises will be expected to have in place to ensure that their systems are trustworthy, that they have capabilities for explainability, for fairness, for assessing stability and robustness of models over time. So that's one big vertical: financial services, banking, insurance, where there is an immediate and urgent pull for this kind of solution. We are also starting to see this in a number of other areas. One of our customers is a major retailer, and they are using machine learning for pricing and marketing related activities. And in that context, if the model goes out of whack, then there is real and significant business value that can get lost. So that there's a very direct connection between the quality of the AI system and the impact it has on the business's bottom line. So that's another area where there's a lot of interest and activity for AI quality. We are also starting to see a lot of interest in healthcare, and interest also from smaller companies, not just the big enterprises, but also from smaller companies and data science teams who are currently have to do a lot of manual work to test and debug their models to ensure that they perform well in production. So I would say that these are some of the few verticals, some of the verticals and use cases where we are seeing attention, with early signals that it's going to be important across the board as companies, big and small, adopt machine learning at scale.
Got it. So tell us, like, why is this complicated for a team to implement on their own? Like, sort of what did you see before your product existed? Like, how are teams solving this or attempting to solve this on their own, and what were some of the challenges there?
Yeah, that's a great question. I think one kind of observation is that this is emerging. This is a new and emerging category. And for a section of the population, there wasn't widespread recognition that this even is a problem. So that's starting to change now. Data science teams were building their models, optimizing for accuracy metrics during train and test, and starting to move those models into production. And sometimes they got stuck because they could not convince their business stakeholders, and models would die, stayed in kind of the R&D stage and did not make it to production. Sometimes they would make it to production, but then not deliver business value. The production performance was nowhere near what the performance was for on the train and test data. And there was a lot of manual debugging and adjustment of models that had to be done. Now, as we move forward in time, folks are also in-house are starting to work on some aspects of this problem by leveraging libraries that are available in open source. So there are open source libraries for explainability and fairness, and so forth. And those are reasonable starting points for the slices of the problem. I would say, as we think about why an independent and complete enterprise-grade product is needed here, there are a few different dimensions to it. One is at an architectural level and platform level, it's extremely important to have a general, extensible, universal platform that can work with lots of different model types, that can connect to lots of different kinds of data stores, and perform at scale. So that's not so easy for data science teams to pull together on their own, because it requires serious infrastructure, architectural thinking, and execution. So that's an area where there is some serious thinking that went into the product that we built. For example, ensuring the universality of our platform, meaning that it can seamlessly work with lots of different model types and data types that are coming out of different model development platforms. And to solve that problem, we've stood on the shoulders of giants, if you will, leveraging a lot of work that other folks have done, like on the ML flow system. And then, so that's the platform level things, the platform level characteristics. Then there's the data science level characteristics. And there, as we talk about, say, explainability, for example, it's a very rich area. And there are lots of different ways of explaining models, but there isn't a very systematic understanding of for which problem, what method works best, or where the limitations are of various existing methods. So one of the things which we have done as part of our product is to have a much more guided experience, and we have some core IP that helps with getting accurate and faster explanations in a way that has significant impact for the business. So just to give you one example, if you think about, let's say, a credit decisioning system, machine learning model, and it's coming up with specific predictions on who to give credit to and who not to give credit to. One of the requirements is to be, and this is required in the US and is increasingly being discussed in other parts of the world as well, is to answer questions like, why was Jane denied credit relative to a set of people who are approved? Now, what you get out of an explainability library is here are the top features, along with feature importance scores that say maybe the income, the debt to income ratio, and the number of delinquent recent missed payments could be the top drivers. If we get into that next layer of detail, one kind of emerging way of consensus is emerging around the use of Shapley value-based explanations for identifying the most important features. This is something that Shaik and I worked on and published a paper back in 2016. And then there have been a series of follow-up work in this area. And as a company, we have significantly improved the performance of the method as well. Now, one of the hard things about computing Shapley values is that it's a very expensive computation if you want to do it exactly. If you have 100 features, that'll require like 2 to the power 100 operations, which is just not computationally feasible to do in a reasonable amount of time. So then the next question is, how do we estimate these Shapley values accurately and fast? So this requirement around accurate estimation of Shapley values while still being very performant, that's a really, really hard problem. And some of the solutions that are in open source work well for certain kinds of use cases, but not for other kinds of use cases. So for example, TreeShap works well if you're trying to find the top features for a tree model, like a gradient boosted model, or a random forest model, and only if you're trying to explain the log odds score coming out of these models. But if you're trying to explain a classification decision, like why was Jane denied credit, the top features can vary a lot. The Shapley values for the most important features can be very, very different based on whether you're trying to explain the classification outcome or you're trying to explain a log odds score. And you can get quite incorrect answers if you're using one to infer answers for the next. And maybe an analogy here is useful. So if you think about the US presidential election, for example, and you're trying to answer the question of which states are the most important in determining the outcome of the election, that's a classification question. Mm-hmm. And the answer to that question, let's say in the 2020 election, was a state like Pennsylvania. If you're trying to instead answer the question of which states were the most important in determining the total electoral college votes that a candidate got, which is a bit like the log odds question or the regression score question, then the answer could be usually states like California or Texas, which are the bigger states. They bring more votes. So now if you try using the answers for the regression score or total electoral vote count score to answer the question about the classification outcomes, you can get very inaccurate answers. And that's where some of the gaps are in some of the existing methods.
Got it. And so, look, what are some of the different differentiations between what you've built and some of the other so-called explainability tools on the market? I'm curious to understand more about sort of your values and the design decisions you made and some of the trade-offs that you considered when you were building a generalizable solution in this space.
Right. So we started getting into some of those topics. I would say that there are some very substantial differences in the core explainability capabilities. We started getting into that a little bit, where when we talk about Shapley value-based explanations, our methods are more broadly applicable. They can work with different types of models. They can work with different types of model outputs, and they're more accurate and performant. If we start getting into some of the other kinds of capabilities, let's say around fairness, around stability of models, some of the key differentiation there is around supporting very rich root cause analysis. So it's fairly common to report metrics related to fairness. And in the fairness literature, there's a rich set of metrics that our product supports, but so do a bunch of other companies in this area. But the metrics are just the starting point of a fairness assessment. So for example, if you think about the disparate impact ratio in an employment application, and it's measuring what's the proportion of women who are hired relative to the proportion of men who are hired. And if there's a big gap in that ratio, let's say women are only being approved or being hired at 80% of the rate at which men are being approved, then the disparate impact ratio will say that there's an 80% disparity between the two groups. That's a very useful metric to signal the start of a fairness assessment, but just reporting that is not enough. The next step in that workflow is to do a root cause analysis that identifies the reason for that disparity and surface that to human assessors. So for example, in the employment use case, one of the reasons for that could be that for this particular kind of job, it required a college degree in computer science. And the proportion of women who applied for this job that didn't have the college degree was much higher than that for men. So if you're able to surface that kind of reason, then a human in the loop can then go on to make a judgment on whether the statistical disparity is truly an indicator of unfair discrimination, or is it for a justifiable reason? And the kind of unfairness that's emerging through this process needs to be addressed not through changes in the data or the machine learning model, but needs to be addressed earlier in the pipeline through interventions in education and so forth. So that's a powerful set of capabilities here around supporting a deeper root cause analysis, which can then inform adjustments to the model or when needed, and adjustments to the training data as well. Similarly, that kind of root cause analysis is also supported in other parts, other kinds of AI quality attributes related to why is the model performance dropping, or why is the model suddenly unstable? Is it because the world has changed in a specific way, so that we can surface that reason and then go on to adjust the model or the surrounding rules? So the core explainability technology, support for deep root cause analysis that supports for fairness, for stability, error analysis that helps with debugging, identifying model weaknesses and debugging them. Those are some areas where there are distinctive and significant advantages over other options in this space. And I think at a platform level, one of the big things is the universality aspect that I touched on earlier, around supporting a rich class of models and connections to data stores, and being able to work with seamlessly with different deployment platforms.
Got it. And on that point, from an implementation standpoint, where does TruEra fit in the modern data stack?
That's a great question. You can think of us as sitting adjacent to the training and to the deployment pieces of the stack, and then integrating with those pieces through certain kinds of connectors. So for example, if I focus on the diagnostics product, which is what model developers use during model development, then the installation and connectivity involves building pipes to get access to the models and to the data sets that are used to train and test those models. So we support several different experiences in this process. One is a web-based UI experience where after a model has been developed, there is a fairly easy way to, using a number of different interfaces, to push the models onto our service along with pointers to the data. And then the developers can use our UI-based product to test and debug and explain the models. And then there's a related experience with notebooks, where a lot of model development in data science happens through notebooks and Jupyter notebooks. And in this other experience, they can just stay in their notebooks and have interface with our service through a set of API calls, and they can see all the visualizations and so forth in the notebook itself. So that's a tighter integration where their life does not change much. They can just stay in their notebooks and work in their usual way and leverage the capabilities that we have for explaining and testing and debugging models.
Got it. Super helpful. So Anupam, we're almost out of time, but I just want to ask you before you go, you've seen a lot in the data ecosystem in the last 10, 15 years through your research and your work on this AI quality problem. I'm curious, like what surprised you most through this journey?
That's a great question. I think one of the things that surprised me the most is the recognition and willingness in enterprises to do the right thing. So in the sense that there's a lot of discussion these days around trustworthy machine learning and responsible machine learning. And some of it is coming because of regulatory interventions and so forth. But what I find as we have engaged with lots of customers in this space is that there are a large number of folks, data scientists, as well as folks in leadership positions, who truly care about ensuring that the machine learning models in the process of delivering business value are mindful of the societal impact that they have. So questions around explainability and fairness and performance characteristics that might end up denying opportunities or offering opportunities in ways that can hurt people long term, those are top of mind things for a number of folks. So I was pleasantly surprised to see that many people are receptive and also very intentional about ensuring that AI technology gets adopted in a way that's responsible. And it's almost, instead of it being like a defensive move in the sense that, oh, if we don't do it, it'll hurt us in some way through regulatory intervention or bad PR, there's increasing recognition that adopting AI responsibly is good for business. That, in fact, not only will it have a positive impact on the world, it can actually boost the business value of the core AI that's emerging from these core AI capabilities. You might be able to reach a broader section of the population and include them, financial inclusion. You might be able to get to new segments that you had not thought of before. And that to me was both a pleasant surprise, and it gives me a lot of room for optimism that we are starting to hit a phase shift where there will be a bigger set of adoption of AI at scale in core areas of lots of different verticals, and that it'll be done in a way that is responsible, and it'll be done in a way that it'll generalize well and perform well in production.
Mm-hmm. Well, as you know, I'm a supporter of the company and your vision, and it's great to hear your thoughts on this broader AI quality issue. I think sometimes, we can get lost in the weeds in simple explainability or model performance matters, and so it's great to hear about your broader perspective on the AI quality space and all the implications of that. So thanks for joining us, Anupam. I'm excited to see how the company tracks, and I'm looking forward to great updates from you in the future.
Thank you, Pete. It was a pleasure to have this conversation with you, and look forward to continuing the conversation. This is a very big area. I would say this is one of the biggest areas that will support large scale and positive adoption of AI and machine learning. And so some of these sub areas that you alluded to, like explainability and model performance and model governance, it's useful to think of them not as separate areas, but under one umbrella around AI quality. And that's the final thought that I'll leave you and our audience with, is to think about all of these sub areas naturally clubbed under the AI quality umbrella. And that will help us, that broader perspective, I think, will help us bring greater clarity and definition to the field and to show its connection to business and societal value.
I agree. Well, thanks for joining us, Anupam.
Thank you. Have a great day.
You too. And thank you to all of our listeners who are out there. We are going to take a break for the rest of the summer, but we'll be back with more amazing guests and new episodes of DC Thursday in September. So everyone enjoy your summer and stay safe and be well.